Today we are going to look at 10.4 Applications of Pythagoras Theorem and its Converse. So please copy down the learning target on your class workbook. I can solve problems in real life using Pythagoras Theorem and Converse of Pythagoras Theorem. So in order to solve the application problems, we can follow the following 3 steps. Please also copy down on your class workbook. Step 1. We have to label the figure, as well as writing down this sentence with the notation in the figures. Step 2. We need to look at the figure to see whether we have any right angle or 90 degree. If yes, then we can apply the Pythagoras theorem to set up equations. If no, then we have to find out the right angle first using the converse of Pythagoras theorem. Step 3. We need to answer the questions by showing the description and the units. So now, example 1. In the water wheel part, the vertical distance between the top and the bottom of a water slide is 9 meters, and the horizontal distance covered is 7 meters. What is the length of the water slides? That means here. Give your answer correct to 3 significant figures. So now, do you still remember we have the 3 steps, right? Step 1, we have to label the figure, right? So now, we can write down this sentence with the notations in the figure, and then we can label A, B, and C in the figure. So what is our next step? We have to look at the figure, right? So now, inside in the figure, we know that this is a right angle. Angle ABC is a right angle. So that means we have to apply the Pythagoras theorem. So since AC is opposite to our right angle, so AC is our hypotenuse. So we have to write down AC squared on one side, and on another side, which is AB squared plus BC squared, and then write down the reason, Pythagoras theorem. By solving the equation, then we can find out AC is equals to 11.4 meters, correct to 3 significant figures. So in our last step, we need to answer the question by showing the description and also the units. So it completes our example. So now it's your turn. Please make a pause before we check the answer. I believe you should have finished the question, right? So let's read the question. Same walked up an inclined road when he has walked 200 meters. The vertical distance he has risen is 50 meters. Find the horizontal distance he has walked. Give your answer correct to the nearest integer. So now, what is our first step? We have to label the figure, right? So with the notations in the figure, then we write down label A, B, and C in the figures. In step 2, since we have the right angle given in the figure here, because angle ACB is a right angle, so we can apply the Pythagoras theorem. So now, because AB, which is 200 meters, is opposite to our right angle, so we have 200 square on one side, and then we put the 50 square and the BC square on another side using the Pythagoras theorem. So by solving the equation, we find out BC is equals to 194, correct to the nearest integer. So lastly, last steps, we have to answer the questions by showing the description and the units. Okay, the unit is meter. So it completes our question, right? So now, let's look at another example. The figure shows a triangular paper cut ABC. AB equals to 4 cm, BC equals to 7.5 cm, and AC equals to 8.5 cm. Find the area of the paper cut. In order to find out the area, we have to make use of the base times height divided by 2, right? But we should find out the right angle in between the base and the height first. So can you see any right angle in the figure now? No, right? So that means we need to first of all find out the right angle first. How can we find out the right angle? We can use the converse of the Pythagoras theorem, right? So now let's apply our three steps. In step one, we have to label the figure. Since we have the label A, B, and C already, so we don't need to write down the sentence. We can go to the next step. Um, because we don't have any right angle in the figure, so we need to find it first. We are going to prove angle B is a right angle. So we take out the longest size, which is 8.5. So this is 8.5 squared, which is equals to 72.25. And then the remaining two sides, one is 7.5, another is 4. Okay, so we have to make the square of them, and then we have to sum them up. So the sum of them will be 72.25 as well. So that means our first part is equals to our second part. Then we can make use of the converse of the Pythagoras theorem to say that triangle ABC is a right angle triangle, where angle B is a right angle. So we can apply the formula to find out the area of the triangle. So now the area of the paper cut, which is the base BC times the height AB divided by 2. So the answer will be 15 cm square. So now it's your turn. You can make a pause before we check the answer. I believe you have finished the question, right? So let's read the question first. A solar collector AC is supported by the triangular stand ABC on a horizontal ground as shown in the figure. So in part A, is angle ABAC a right angle? Explain your answer. BAC means here. This is the angle BAC. So how can we prove that it's a right angle? Yes, we have to apply the converse of the Pythagoras theorem. So let's follow the three steps. Step 1. Do we need to label the figure? In this case, no, right? Because we have already the A, B, and C in the figure already. So we don't need to label it. So step 2. Uh, because we don't have any right angle, so we have to apply the converse of the Pythagoras theorem. Okay? So we can take out the two shorter sides, 7.5 and also 18. So we make the square of them and then we sum them up. And then the sum will be 380.25. And then later on, the longest size, which is 19.5. So we make the square of it, and it is also 380.25. So we can apply the converse of the Pythagoras theorem to prove that the triangle ABC is a right angle triangle, where the angle BAC is 90 degrees. So it's part A. So now part B. By considering the area of the triangle, find the height of A from the ground, correct to three significant figures. So we have to find out the height. So we need to let h be the height of A from the ground. So in part A, we have known that this is a right angle. So that means we may let this one to be our base, and this one will be our height. So we can find out the area of the triangle by using 18 times 7.5 and then divided by 2. Okay, this is the area of the triangle, right? But in our second approach, we can also make use of the BC as our base and H to be our height in order to find out the area as well. So in this case, in our second approach, the area of the triangle will be 15.5 times H and then divided by 2. Because we are talking about the same triangle, so no matter we use the approach 1 or approach 2, the area should be the same, right? So we can set up the equation like this. This is our second approach, where this is our first approach. So by solving the equation, then we know that H will be 6.92. And then in our last steps, we have to answer the question by showing the description. The height of the decoration is 6.92. The unit is cm. So that's all. And now you can make use of the worksheets for more practice.